Today we start the new chapter electrostatic potential, capacitance and dielectrics. This is the second chapter in part 1 textbook of NCRT. So we'll start with the topic electric potential difference. So in the first chapter we have seen what is a uniform electric field. Electric field is a region surrounding a charge where its force can be experienced. Now in an electric field there is a potential and potential difference. Now to understand the concept of potential, we'll consider uniform electric field. Suppose we have a region like this. The region is a uniform electric field. So this is a region of a uniform electric field. At each and every point electric field is uniform, having same magnitude and same direction. Let us consider 2 points in the uniform electric field. These 2 points A and B. A and B. So at the points A and B, the potential is different. Potential difference means between B and A. Potential difference means the work done to move a charge from one point to the other. So this is a directional electric field. Electric field is directed towards the right side from left to right side. Now suppose I have a charge Q. I have placed a charge Q. This is a positive charge Q. I am going to move the charge in this direction from B to A. So definitely to move the charge from B to A, I need to do some work. Let W be the work done to move the charge from B to A. Then if W is work done, I am moving the charge in this direction. Moving the charge in this direction. But we know that the charge is an electric field. So the charge will experience a force. And the force experienced in the same direction electric field. This is the force experienced on the charge Q. This is the direction of movement. I can say between A and B, the distance is dr. Dr be the distance. So in this distance, I am moving the charge. So there will be force in this direction towards the right side direction force, displacement towards left side direction. So W is the work done. Then Q is the charge moved. So what is the potential difference between points B and A or A and B? I can write potential difference V between A and B is equal to moving charge from B to A is equal to work done divided by the charge. This is a basic definition of potential difference. Potential difference between 2 points in electric field is work done divided by charge. Work done to move a unit charge from one point to another is termed as potential difference. Or in other words, we can write potential difference VAB, we can write VA minus VB. Difference in potential A and B is equal to the work divided by charge. So what will be the SI unit? Potential difference SI unit. Work as unit is joule and charge as unit coulomb. Joule per coulomb is SI unit. Otherwise it is known as volt. Volt or joule per coulomb is a SI unit of potential difference. So in electric field there is potential difference between 2 points. Then potential difference between A and B is equal to VA minus VB is equal to the work done divided by the charge. If W is a work done to move a charge Q, work divided by charge will give potential difference. It is the work done to move a unit charge, that is equal to potential difference. So you have got a basic definition and equation. Now we need to relate this potential difference with the intensity. So we have seen that we are moving a charge Q from B to A, dr is a distance to be moved. And there is a force experienced by the charge in the opposite direction because there is a directional electric field. Charge is kept here. So the charge will experience same charge. The positive charge is there. Electric field in this direction. The positive charge experience a force in the directional electric field. Now we are doing we are exerting external force against that against the force F. So we need to do some work. We need to move the charge from B to A. dr is a distance. Now we have learned that with the work done W is equal to small work done. I need to move the charge from B to A through a distance dr. Small work done. What is equation of work done? Work is equal to dot product of F and the displacement F dot dr. Or I can write F is equal to F dot dr is equal to expand dot product is F force into distance into cos theta. What is cos theta? What is theta? Theta is angle between F and dr. F is in this direction. dr is in this direction, they are opposite. So I can substitute 180 degree instead of theta. So F into dr into cos 180. What is cos 180? Cos 180 is minus 1. So I can write dw is equal to F into dr into minus 1. So you'll get the work done is equal to what? Minus F into dr. F into dr. I need the potential difference. What is potential difference? The work done divided by the charge. So I can write equation. So potential difference between A and B, I can write a V. For small dV, I can write dV is equal to difference in potential. VA minus VB or dV, or simply we can write VAB. So dV is equal to work divided by charge. This is work. What is the equation of work? Minus F into dr is equation for work from this equation. Then divide by the charge which we move. Q is a charge which we are moving. So work by charge. What you are getting? dV is equal to, what is force by charge? You have learned first chapter that F is equal to Q into E, that we have learned. So what is force by charge? Intensity. So minus E into dr. Or we can write E is equal to minus dV by dr. From this, electric intensity has got one more unit. dV, volt is as a unit, dr distance. So what we can write? Volt per meter is another unit of electric intensity. So E is equal to minus dV by dr as an equation. This is a relation connecting what? Potential difference, distance and electric intensity. E is equal to minus dV by dr. So if you want to move a charge in a uniform electric field, we need to do some work. These 2 points are very close line points. So intensity at these 2 points will be almost the same. Very close points. Also the electric field is uniform. So in this uniform electric field, we are moving a charge from B to A. There is potential difference, work by charge. Now the work done to move the charge against the electrostatic force, because force will be created in this direction on this charge. What is a force? Force is equal to electrostatic force. This electrostatic force. So we are moving the charge in this direction. dr is a displacement. What is the work done? F dot dr, dot product. F is equal to work done is equal to dot product of force and displacement. So cos theta. Theta is the angle between F and dr. F in this direction, dr in this direction. Displacement is along leftward and around rightward. There is force due to electric intensity, electric field. Cos 180 means minus 1. So you have got dw is equal to minus F into dr. But by definition, potential difference between 2 points A and B is equal to work by charge. This is the work done. And we need to divide by charge because we need a unit charge. That's why we are dividing the charge. So dV is equal to minus F into dr by Q. F by Q is equal to electric intensity. This is a relation connecting electric intensity, potential difference and distance. So we can say electric intensity is the negative gradient of potential. Okay, thank you.